Buddy, I wanted to take a couple of minutes and walk you through example 7 that we didn't get to yesterday. So in example 7, what they're doing is giving us the visual of a graph of a rational function. And what we need to do is give the intervals of the x values that will make our output values for the function less than or equal to 0. So we've talked about it in this type of way before, where that means that my output values are in negative y territory. So that's going to be something that looks like this and like this. And because I have an equal to down here, that means we have to include those x-intercepts as well. So in interval notation, we have to put our values from left to right. So the furthest left that this thing goes is right up against that vertical asymptote or undefined value of -3. And because it's undefined, I'm going to enclose it in parentheses rather than brackets. That goes up to my x-intercept value of -1. And because I'm supposed to include the x-intercept values, I'm going to put that in brackets. This symbol that looks like a capital U means union. It is from set notation. I haven't talked about that a whole lot with you guys, but it really just means the word and. It's the same thing as the word and. So when you see this, which you likely will see in AP Pre-Calc, we're going to start using that a little bit more in class, know that it just means the word and. My output values start being less than or equal to 0 again at the x-intercept of 2, and because of the equal sign in this symbol, I want to include that, so I put it in brackets. That goes all the way to +3, and I'm going to include that in parentheses rather than brackets because it is an undefined value. All right, next one. Part B. Now we're looking at where my output values are greater than 0, so anything in positive y territory. So working from left to right, I would be looking at this curve up here. That's definitely in positive y territory. It looks like in between my two x-intercepts is positive y territory. And then again, this piece up top, but over on the right-hand side, is in positive y territory. This time, keep in mind, we do not want the equal to 0, so I don't want to include my x-intercept values of -1 and 2, so I'm going to use parentheses with those. So let's get our intervals written down because we have 3 pieces, separate pieces highlighted. We're going to have 3 separate intervals that we need to record. So this thing is going to happen from x values of -infinity up to that x value of -3 that is undefined, so that must be in parentheses. And that middle piece goes from -1 to +2, and remember, because there's no equal to, I'm putting those in parentheses. And this piece over here to the far right starts up at just to the right of that undefined value of 3 and goes all the way to +infinity. All right, now the last one that we want to take a look at is where my output values are greater than or equal to 1. So this is that output value that's equal to 1. However, we don't have any function values that are equal to 1 because this asymptote, as far as I can tell at least, is guiding our end behavior. We don't have anything obvious from the graph that makes it look like we're crossing that asymptote. Keep in mind, horizontal asymptotes can be crossed. Vertical asymptotes never can be, but horizontal ones sometimes can be. We can talk about that in more detail later. So where we're greater than 1 is simply these 2 curves out here on the edges up here at the top. So those values are going to be from -infinity up to -3, not included because it's undefined. And then on the other side of 3, again, undefined, so not included with brackets. And that goes to +infinity. And there you go. That's that. So you guys should now be able to do those extra problems on the worksheet, the 3 that have the graphs. And if you have any questions, please let me know when I see you back in class on block day. Thanks a bunch and have a great day.